Hi everyone, welcome back. So let's start with the next topic of our foundation understanding, which is basically introduction to machine learning. So after completing all the essential parts of Python, we move on to next important topic, which is a foundation topic to our NLP module, NLP course. So, machine learning. So, for those who are not aware and for those who already know, let's understand machine learning. Machine learning is a branch of artificial intelligence, or if I say in a very simple words, machine learning is like teaching your computers to learn from your data and make some predictions. So, as I told you, our computers are not able to understand our human language, our human English language, Hindi, Spanish, Punjabi, French, German, whatever language it is. Computers or machines are not able to understand that thing. Computers or machines are only able to understand their data. So we are supposed to we allow computers to learn from our data, learn from our experiences without being explicitly programmed. So it's like making your computers learn from the data and make some predictions or understand some predictions. So we can say instead of writing rules for every situation, we give the machine some of the data, it learns from that data and make predictions based on it. So what I mean by here is I just give some of the data to my machine, to my computer, to my program. Based on that data, my computer is going to learn by itself. My computer is going to understand. Like I just summarize so many words all together to my machine. For example, my name, Yashi, Verma, NLP, Python, programming language, all these individual words I provided these words to machine, and machine is going to understand, go through that data and understand by itself. It is going to learn all the patterns, like how the words are submerged, what is the meaning of them, where to write that specific word and all the everything, and then machine is going to make the prediction. Let's say if I say my name is Yashi Verma, is that a, or if I say I like your product, so is that a positive review or a negative review? So based on the previous data we have provided, machine is going to predict that it's a positive review. So that's what machine learning is, making our computers to learn from our data and make predictions for us. For example, if you feed a machine lots of emails labeled as spam or not spam, then machine is going to detect the spam emails automatically in the future. So for example, we just wanted to create an application or a project where we want to create a software where it should detect the spam and not spam emails. Okay, so now to create something like that, how is your computer going to understand what is spam and what is not spam? So before that, we will be training with lots of emails, like thousands of emails, emailed as which are labeled as spam and not spam. So after going through all those emails, understanding those words which are present in spam email, understanding those words which are present in not spam email. So after going through all the learning and everything, machine is going to treat, understand itself, make itself comfortable. Like I would say, I won't say the comfortable, but yeah, machine is going to learn through all the patterns and everything, and after that it is going to automatically predict for us that which email is a spam or not spam. So similarly, we can train machines or computers, we can write a program where a machine is going to identify a fruit as apple or a orange. So the computer does the same thing. Like for example, if I tell you, if you see so many apples and oranges, so I can identify which of these new fruit is apple or orange. Okay, like when I was kid, when we were kids, our parents taught us, right? Like this is an apple, this is an orange. We understand with the color, the texture, the taste, and everything we understood, right? With machines, instead of taste, so the same structure machine is going to also understand the color, structure, everything. We are going to train that. We will be the parents for our machines. Similarly, computers also does the same thing. It use those training data and understand itself. Now, there are different types of machine learning available. Like there are multiple types of ML that we will be understanding. So the first type of machine learning language, like we divide machine learning into three different types. First is a supervised learning, like the different ways of learning the data. So first is the supervised learning. So supervised learning is making your model learn from your label data. So what happens here is in supervised learning, we make a machine learn with both the input and outputs. For example, the spam and not spam email. I will be labeling my emails as spam and not spam. So that is the input, that is the output. With all those inputs and outputs, machine is going to understand and then it is going to predict the new output when you provide. So similarly, let's say if I make machines have to identify if it's a human being, okay, or let's say if we are creating a face recognition application. So in that application, what we're going to do, I will be training the face. Let's say we will be clicking five thousands of faces whom which we wanted to identify. Or let's take an example. Let's say we have a class of 50 students and they want to inbuild a face recognition attendance system where we want to track the attendance of an individual students based on their face recognition. So for doing so, what we're going to do is we'll be first training the 50 samples or more than 50 samples. For each student, we'll be sampling with 100 images to the machine, which will be labeled as the name of the student. For example, for me, so my face will be clicked from a camera from all the different angles, right, left, front, not back, but like the top angle, the bottom angle, like from every angle my face I will be we will be clicking a lot of pictures of my face. Then we'll be providing those pictures to the machine and labeling them as Yashi Verma. Similarly, we're going to do for all other 50 students. So what machine is going to do, it will understand, it will learn itself, like if the feature has this, then that's Yashi Verma. If the feature has that, then it's in another student. So now when the face recognition system is built, when I come in front of it, so machine is going to predict, yes, that's Yashi Verma. It will mark my attendance in front of it, Yashi Verma present. So that this how supervised learning is, where you train your models with the input and output both. So the goal is basically we just want to make the prediction based on the new output. So we already had an example of that face recognition. Similarly, you can also have the example of house pricing, like based on the in size, location, rooms. We provided so many samples to a machine with a price to them, and now the machine is going to identify what's the price of the house based on the size location that you provide in future, which is like a new input if you provide. So now for the supervised learning, we have multiple algorithms, which is like linear regression, logistic regression, decision trees, random forest, support vector machine, and neural network. Now, if you're someone who is new to machine learning, we already have a machine learning course available. You can go through it, understand machine learning in detail. Today, like for this specific course, we are focusing on NLP, so we won't be covering ML in the detail. It's just the basic that we need to know before starting with NLP. So yeah, these are the algorithms that are available for the supervised learning. So let's create a supervised learning examination, or let's create a supervised learning example. Like let's create a model based on supervised learning. So let's jump back to the code now. Let's say I want to labelize my text, like I just want my machine to understand if a text is positive or negative. So for positive and negative, we'll be using 1 for the positive and 0 for the negative. So let's create the sentiment classification model for based on a supervised learning. So before starting with it, we won't be creating everything from the scratch. We'll be using the functions and modules that are already available with Python. So first thing is we will be using one of the way of sentiment and like the supervised learning. For that we'll be using logistic regression algorithm. So we need to first import logistic regression. Along with it, we also need to import count vectorizer. Count vectorizer is going to convert our text into a form which is understandable by a machine. So I'm going to use from sklearn dot feature underscore extraction dot text import count vectorizer. Perfect. See, my Python is already suggesting me the way. Why? Because I've installed a pylons extension to it. So from the sklearn dot feature underscore extraction dot text, it's a library. So that specific is a library. From this specific library, we'll be importing this function, which is count vectorizer. So now see, if you ask me how I got to know that we need to use this function from that specific library, as from the practice I already know it, but if you're a beginner, go to that Python library functionality I told you, like just search to the Google, go through all the libraries and functions that are important, that are possibly going to be used. So from there, you will have the understanding. Second is the model. Everything is present in sklearn. Sklearn is one of the module which contains all the feature extractions, all the algorithms and everything that is possibly required for machine learning. So from sklearn dot linear underscore model, we will be importing logistic regression. So logistic regression is basically a linear model. So from the linear model library, we'll be importing logistic regression function. Now comes the part of providing the text to a machine. So I will be first training my machine, then I will be predicting it. Okay. So let's say, let me train my machine with so many samples. Okay. So let's start with the samples written as text is equal to, I will be giving, let's say, 4 to 5 text to my machine with the labels as positive and negative, and then I will ask my machine to predict for me. So let's say I write, I love this movie. So this is basically a positive, right? So we'll label that later. Second, let's say this film is terrible. Every text that you write in Python is always written in double quotes. Now, so they will be mixed of so many emotion sentences. We are going to provide positive, negative, and all the mixed sentences, and we'll also be providing the labels because in supervised learning we use input and output both. Next, say I will be writing amazing acting. And for the next sample, let's say I write horrible direction. Yeah. So it's like 4 samples I provided, positive and negative. Now I will be labeling those samples. I'm using labels as a variable where first label, which is I love this movie, is positive. So we specified 1. This film is terrible is negative. So we specify 0 for the negative. Then amazing acting 1 positive, horrible direction negative 0. So we just provided label to all the text that we have. Now we will be training a model with all the text and the labels. So the machine is going to understand. Like if you have this word love, then that's positive. If you have a word which is like amazing, then it's positive. So if you have a word like terrible or horrible, then it's negative. We humans also understood in this way, right? Similarly, machine is also going to learn itself. Okay. So first thing is we need to first have all the text transform. So we'll be creating another variable which is vectorizer is equal to, we'll be calling the function which is count vectorizer, and then we'll be creating a variable x is equal to vectorizer dot fit underscore transform, and we pass all the text that we have. So what we'll do is it will vectorize a text. What I mean by vectorize a text is it will for each sentences, it is going to convert each sentence into single words. So for example, for I love this movie, it will be splitted into individual words. It will be like I, then love, then this, then movie. So for all the individual words, computer is going to learn. Like if you have I, if you have love, if you have this movie and all these different words, then it is positive in nature. That is how, not for a whole. Computer cannot understand whole sentence. It is only always going to split its the sentences into words and then understanding each word. So that's what we did by using this count vectorizer function. Now we'll have a model. So model is equal to logistic regression. We call the logistic regression, and then we are going to train a model. So we'll be using model dot fit. How you're going to train it? First, we need the text that is X, which is vectorized form, and second, we need the labels. So by using the labels and the text, we are going to predict the model. So for this part, all the learning is happening. After we'll make a prediction. So let's say I want to print first, I want my model dot predict. So model dot predict is going to predict whatever I will be performing. So before starting with that, we have this vectorizer dot transform because every time we want to transform our text into small words, and then we will ask our what I would say, then we will ask the model to predict something. So let's say I write, I enjoy this movie. Now let me just predict one thing else. Okay, something which is negative in nature. So now I'm going to predict model dot predict bracket vectorizer dot transform, and then we provide the text. Let's say it was boring. Okay, so we have a one positive and one negative. So if I like distribute it for them, so model dot predict is a function which is going to predict the functionality that the model has learned from all about functionality. Okay, all about steps that we have written. This vectorizer dot transform is going to transform the sentence that you are provided into individual words. Based on those individual words, model is going to predict is it a positive or negative. For the whole sentence, model cannot. Based on individual words, model can understand. Now let me run this. This okay. See, I am getting one for this as well, like which means I am not getting the appropriate prediction here. Okay, that is definitely possible. That scenario, it is possible. See why it is possible, because I have only trained my model with 4 samples. That is very less. Like we used to train the models with 1 lakh of samples, more than 1 lakh of samples. Then it will going to predict something accurately. Currently the accuracy is very less. Because of that we are getting prediction as wrong. I Let me change it. What if I change it? I hated the movie. Or we already have. Okay, let me use something which already there. I Okay, let me make it movie is horrible. It was amazing. Now let me run this. Okay, now I got the correct prediction. Why I got the correct prediction? Because based on my data, I already have a horrible word which is labeled as 0, which is negative. So my model understand that it's a negative. And we already have an amazing word, so model is going to understand. If I provide a new word here, model is not going to predict 100% accurately currently because of very less number of data. So that's a thing in machine learning you should know. In machine learning, we always train the models with more and more amount of data that is possible to accrue an accuracy till 99%. There is never a model existing to current date where the accuracy is more than like it's around 100%. There is no such thing which is around 100%. Every time it's the accuracy is always like 99.8, 99.7 or something like that. We haven't achieved accuracy till 100%. So yes, that is how the sentiment classification model we have created, which is basically based on a supervised learning. So this was all about the understanding of supervised learning.